In this video, we're going to construct the tangent function. To do that on Geometer Sketchpad, you have to plot up any arbitrary point anywhere on the screen. Since it's already highlighted, you go transform, translate, and it should already be on polar, and then the distance is 1 centimeter and the angle should be 0 degrees, and then just hit translate. Then you're going to want to construct a ray from the original point to the translated point. Okay. Oh, all right. And then you're then going to create a circle with the center point, with the center being the original point that we plotted, and then the point on the circle has to be somewhere on the ray. Okay. Now we're going to hide the ray, or hide the point. I'm sorry, the point on the ray, the translated point. Okay, and then we're going to hide the ray. Right click on it, and we're going to create the radius from the center point to the other point on the circle. Okay, and we're going to have to construct a ray starting from the center point going to the circle. You go to the ray, start at the center. The other point should go on the circle. Okay. From here, we're going to construct a segment from the center point to that point on the ray that's also on the circle, and then we're going to hide the ray. So right click, go to hide ray. That way we don't have to see the ray because we're not using it. So at this point, we're going to click the bottom point on the first segment we created on the right, and then the circle, and then the other point on the circle, and click construct arc on circle. So since we're focusing on only this arc, the rest of the circle, which is dotted, we can just change, make it thinner. So display, we select the circle, then go to display, line style, and then hairline. That makes it thin. That way it's still there, but it's not so bold. Okay, so since we're trying to get the radian measure, that's how you get to the tangent, you have to measure the arc length. So you double click on the arc length, go to measure arc length, and then to also get the radian measure, you have to measure the length of the radius. So you click the radius, measure length, and what the radian measure is the arc length divided by the length of the radius. So we're going to hit command equals on the keyboard, which is calculation. It's the same as going to number calculate, and we're going to select the length of the arc, or the arc length, divided by the length of the radius, and that right there is the radian measure of the angle EFD. And as you can see, as we drag E around the circle, once we get to closer to pi, should be about 3.14, if I can get it there, 3.14. As you go around at about 2 pi, it should be about 2 pi, which is 6.28. Okay, just to simplify everything that's on the screen, we're going to rename the calculation that's on the screen, which is the arc length over the radius measure. Just right click on it and go to label measurement. We're going to name it alpha. It doesn't really matter what you name it, but we decided on alpha, so we'll go with that. Alright, just to avoid some of this clutter, we're going to move the circle just away from all the units and stuff so it's easier to see. Alright, we're going to want to construct a coordinate plane with the radius measure being each unit. So click on the radius, go to graph, define unit distance. And what this does is no matter if we change the length of FD, the coordinate system will follow. So no matter what, we can drag the circle and it'll always line up with F on the origin and D on 1, just like that, as you can see. Okay, I'm just going to move the circle out of the way 1 second. From here, we're going to construct a tangent line through point D. So you click this segment, click point D, go construct perpendicular line. And what this is the tangent line to the circle through point D. Okay, to actually get the function, we're going to have to change FE from the segment that it is to a line. So you click using your toolbox, go to the line, click on point F, bring it to point E. Oh, GSP still has it on thin, so we're going to change it to medium, back how it used to be. Okay, and while we're at it, we're going to change this line, the tangent line as well. Line style, medium again. Okay. Move this over so you can see the points. And from here, we're going to click this line FE and the tangent line here. Go to construct intersection. Okay, in this point here, the new intersection, I'm going to label it so I can reference it so you understand what I'm saying. Okay, GSP big G, so we'll go with that. And as you can see, as I move FE, G follows. And also when it goes on the bottom side of D on that same line, it also is still the point G. And this point G, we can construct a segment GD. So you go here to toolbox segment, go from G to D. This length GD here is the tangent of the angle alpha. Alpha here is EFD, like it is 0.82 radians. So this segment here, GD, is the tangent of that angle. Since GD is what we're going to focus on, we're going to click on the segment GD, display, color, and let's go with light green to help you visualize it. So once again, as we move it, GD follows. Okay, now we want to think about the arc length on the graph. So we will copy the arc ED right here and place it on the x-axis. So to do that, so GSP understands which direction we want to copy it. We are going to plot a point. So you go to graph, plot point. And you want 1 and 0. Plot that. Click done. From here, we're going to right click on alpha. Click mark scale factor. Okay, and from here we're going to double click the origin. Then click 1, 0 like I said, so GSP understands which direction. Click transform, dilate. It's going to say over alpha, about center H, which is perfect. Click dilate. From here, as we move the angle around, the new point is also moving with the length of the arc length ED. Okay, and just to use some more colors to help you guys. Once again, as we move this point is the one that's moving. So since we don't need 1, 0 anymore, we can click it, Command H, which hides it. Then we can click this point and this point. Command L creates a segment. And I'm going to right click on that as well, change the color to the darker green. As you can see, this line segment matches this length in color and in length. That way you can see as it goes, and as you can see here too, as the arc just about reaches one full circle, or 2 pi, the point gets about to 2 pi, and once we fully go all the way around, starts back over. Alright, I'm just going to move this over really quick. Sorry, okay. So we're going to need to look at the y value of this point G. So we click on G, and it's measure, ordinate, or y. Click on that. Do the same thing for point D, so click on that, measure, ordinate. Okay, from here we need to take the difference between the two, between this value and this value. So we're going to command equals, or number calculate, same thing, and then take yg, y sub g, minus y sub d, and what this number is, 0.81, I'm sorry, is the y value of the tangent function. So as we make the angle bigger, or smaller, the value changes with it as well. And this measure also as well is the tangent of the angle here, alpha. Okay, from here we need to take this measure of the angle alpha and this measure of the tangent of alpha and plot it here on the coordinate plane. So you're going to click on alpha and then the tangent right here in that order, and then graph, plot as xy, and that gives you this point. And as I move the angle around, you can see it kind of looks like tangent curve, the way it curves up. Okay, just so we can see, to visualize the tangent, the graph, we're going to connect this endpoint right here, which is the arc length, to this point, which is the tangent, just so you can see it really fast. I'm going to take the tangent and measure that length, and get that, and then measure this one as well. They should match because this tangent is basically just moves right here, and that's what this point J is. Okay, as I move E around the circle, it looks like it might be a tangent, but we're not sure, so we're going to generate a locus so you can visualize it even more. So you got to click on point E, then this new point J, or the XY plotted point, and then click construct locus. As you can see here, this is the tangent function. Once again, I'll just change this color to the light green that it is up here. Just one thing to notice from right here, when it goes exponentially large, and then once I get past pi over 2 for alpha, it flips over the x-axis and starts going negative. What that is, why that is because this line FE never actually intersects with the tangent line. So at that point, there is no distance GD because there is no intersection. So that is why there is an asymptote at pi over 2 and at 3 pi over 2. Okay, the last thing we're going to do here is just create an action button to animate this point E. So we're going to click on E, go to Edit, Action Buttons, Animation. There should only be one characteristic about it, counterclockwise, which is obviously this way, around this circle at medium speed. It doesn't matter really what speed, you can set however you like. You could go with medium, doesn't matter. Hit OK. And what that does is it creates this button here. It's basically a light switch, on and off. Click it, it turns on, and it moves the point for you along the tangent function, and once you click it, it'll stop. And that's it. And that's how you construct a tangent function on Geometer Sketchpad.